Hello everybody, welcome to Natural Science Grade 8. We're on week 3, lesson number 2. Our lesson would be 45 minutes. We're going to do it like yesterday where I will teach the lesson and then we will have a question and answer time a little later. So I'm going to show you, I want to show you first what our lesson is about. We're going to do expansion and contraction of matter. Then I'm going to define what expansion and contraction is. And I'm going to explain expansion and contraction in terms of the particle model, which is the solid, liquids, and gas. And that would give you more consolidation of understanding the particle model method. And then I'm going to explain to you how expansion and contraction in terms of particles work in a thermometer. But before we do that, what I want to do is to actually answer the questions that you had and information that you gave me from yesterday, because we didn't get a chance to do the question and answer yesterday, and I think it's important to consolidate the information. So basically, we said that denser materials have a greater mass in relation to their size. That means that is why they feel heavy. So mass is the amount of matter an object contains, while volume is how much it takes up space. So if we remember, mass is the amount of how much matter an object contains, and then we have volume is basically how much space it takes up. Okay, so one of the learners gave me basically summarized what I said about the experiment that I gave you for sand, water, and air. So you compare the density of sand, water, and air. Now, if you weigh a small amount of water that has the same volume of grain of sand, the sand will weigh more. So that means if you take the same amount of sand and the same amount of water, and if you had to weigh it, then you want to know which one is more dense. So we say the sand is more dense and the sand will sink into the water. Now, this is because the sand is a solid. Now, even though you may think, well, why is sand as a solid? Well, basically, each grain of sand is a very small solid because it can hold its own shape. So any substance that can hold its own shape is basically called a solid. Now, the learner that posted the answer that said that sand is more dense than liquid and liquid is more dense than air, now this is correct. So I'm just going to recap over here. So we say sand is more dense than a liquid and a liquid is more dense than air. Now you can visualize the particles in a solid and then the particles in a liquid, then visualize the particles in a liquid and the particles in air, in a gas, and then you'll find why it is more dense. So the learner that gave the order of density from most dense to least dense, it was sand was most dense, then it was water, and then it was air. So then another learner asked, why is oil bad? So basically, oil is a sticky substance. So with regards to eating food that is oily, you need to understand that oil doesn't have any nutrients in it. And then because oil is a sticky substance, it basically slows down your blood flow and it damages your blood vessels. So the oil to use to cook, basically the good oil is either canola oil or olive oil, because it has the least amount of saturated fats. That means that the fats that it has doesn't clog your arteries. Now, in terms of oil that is used for machinery, like in your car or in machines, because any machine needs oil, most machines need oil to work. So basically, when they pump oil in the sea in underground pipes. So you need to take great care of transporting that oil as well because of its sticky nature, because it sticks to you. And then if there's a hole in the pipes that transport it, and if it spills, then it's going to be harmful to your sea creatures and your plants and your animals because it's going to stick on their body. And just like how if you consume too much of oil, then it's going to stick onto your blood and clog your blood vessels. Then just like how for the sea creatures and the plants, and it sticks on them and it prevents them from breathing, and eventually it is dangerous. So we need oil to live, yes we do, but also we must treat it in a manner that protects us. Also eat it in a manner that protects our body, and treat it in a manner that protects our environment. Okay, so then another learner wanted to know, do we always use the formula to calculate density? So yes, we always use this formula to calculate density. So its density is equal to mass over volume. So D is equal to M over V. Mass is M and V is volume, and the D is density. So one of the questions that they asked was, how do we know which one is the mass, which one is the volume? Right, and sometimes they give you the density and you have to find out either the mass or the volume. So we learn what the mass, the volume, and the density of the substance is by checking the unit of measurement. So we check, oh, sorry, I didn't underline straight. So it's the unit of measurement that we need to check to find out whether it is a mass or a volume. And this unit of measurement is usually next to the value. Okay, so for example, in the example we used yesterday, we said butter is equal to 500 grams. So now this G here that I have here is the grams. So G is equal to grams. So when you see G, or if you see kg, or any form of weight, unit of measurement, so the most two popular ones is grams, which is G, and kilograms, which is kg. So this tells us what the mass is. And then so the 500 grams is basically the mass. Now, when they give you, say, 550 ml, so basically the ml here tells you what the volume is. So if we look at the unit of measurement, we'll know which one is the mass, which one is the volume, and then the unit of measurement for density is grams per milliliter. That means how many grams is in a millimeter. Okay, so I hope that answers your question as to wanting to know how to identify which one is the mass and which one is the volume. So you identify it by using the unit of measurements that's next to the value. Right, so what I did was just to make it easy for you, and you can take some pen and paper and write these formulas down in case you don't know how to convert them. So from the formula D is equal to mv, we can make up formulas to calculate the mass and the volume if they give us the density but they don't give us the mass, or they don't give us the volume. So here's the formulas here. So to calculate density, we use D is equal to M over V. So you can write that down. To calculate density, we use D is equal to M over V. And then if we're going to calculate mass, we use the formula M, which is mass, is equal to density times volume. So M is the mass, density is a D, and V is the volume. And this multiplication sign is you multiply it. Okay, that was a bit too soon. Then we can say we wanted the formula for volume. So for volume, it's basically V is volume, is equal to mass divided by the density. So it's mass over volume, m over v. So these are the three formulas you need to calculate when you're doing density. So what the first one I'm going to repeat is d for density, mass over volume, m, which is mass, which is density multiplied by the volume. And to calculate the volume, it is v, which is equal to m divided by d, mass divided by the volume. Okay, so there was also a learner that wanted to ask me about how do we know what are the independent variables and what are the dependent variables. So an independent variable is the controlled inputs. Controlled inputs, that means what can be manipulated, what can be changed. So when we say what can be manipulated, we mean what can be changed, means we can control it. So in that water, sand, flour experiment, the independent variable was the volume, because you can control the volume that you are going to use. And you can perhaps use a 250 gram cup, or you can use a 500 gram cup. But then whatever volume you're going to use, it must be consistent throughout for each variable, each dependent variable that you're going to use. Now, the dependent variable is basically the variable that is being tested or measured, which was basically the sand, the water, or the flour. So the dependent variable is what is being tested or measured. So I hope that clarifies what you need to know about dependent variable and independent variable. So we're going to move on to today's lesson, which is basically expansion and contraction. So there is a learner that wants to know, I'm just trying to access it, 1 minute. Okay, so when I said sand is a solid, the question was, why can it dissolve in water particles then settle? So it's actually not dissolving, the solid is not dissolving in the water particles. When you put the sand in the water, it's not like how you put sugar and water, sugar into water, and then when you stir the sugar, it dissolves. The sand, because the density is different, it just settles at the bottom. Now, the salt and the sugar, even though those are regarded as solids because it can hold on its own, it has substances in it that allows it to dissolve in water. But the sand, it doesn't have a substance like sugar and salt that allows it to dissolve in it because of so it's dense and it just stays at the bottom, so it cannot dissolve in water. So sand just stays at the bottom of water. So, and it stays in its original form. So it settles in its original form. It does not mix. I hope that answered your question. Okay, so then we had, before I do this, let's see. Have you ever been inside a tin roof? Now, on a hot day, if you were inside a tin roof, you often hear that the metal roof panels groan and it creaks. Now, you may ask yourself, well, why would that happen? So let's look at this house. Now, this house, this roof here is basically a tin roof, and it makes noises when on a hot day. And let's find out why. So some materials become slightly larger when they are heated. So we say that it expands. So when materials become larger, we say it expands. The materials can also shrink. So when these materials shrink, we say that it is cooling down. So when it is cooling down, we say that it contracts. So you may think, now, if this is a solid, why would it expand or why would it contract? So we're going to find out why, and it's because of the particles inside the solid and inside the solid. So the definition of expand. So we say heat causes the molecules to move faster. Thus, a substance would expand. So now, because when you heat something, these molecules inside the solid, for example, this tin roof, is moving much more faster. So because it's moving much more faster, it expands, but it doesn't expand by so much that you're going to notice. It just expands a little bit. And now heat is converted to kinetic energy, which is movement energy. And this movement energy causes it to expand. Now to contract, contract means to shorten or reduce its size. That means to become smaller. So when you cool it, it becomes smaller or it reduces its size. So contraction occurs when it is cooled. Now the particles move closer together and it slows down, it causing them to contract. So I'm going to say that again. The particles move closer together and it slows it down and it causes it to contract. But in expansion, the particles move fast and they move further away from each other. So that's how it expands. Okay. And then I'll explain that to you in the next few slides that comes up. Now, the metal roof panels expands and contracts at outside temperatures. Basically, on a hot day, it's going to expand, and on a cool day, it will contract. Now, when this happens, the panels scrape against each other, and it also scrapes against the nails that holds it into place. And the scraping of the metals basically causes it to make the creaky or the groaning noises. Now you may ask yourself, how is it possible for materials to expand or to contract? Now before I move to the next slide, I want you to think how it is possible for it to expand or to contract. And think of the particle model. Okay, so now to understand this phenomenon, I'm going to try to explain it to you in terms of the particle model, so you'll get a better understanding of how it will expand or contract. Just let me see. Okay, so I will explain. I'll explain this slide slowly so you'll understand. So solids, liquids, and gases, it tends to expand and heat and contract when it is heated, it expands. So in all solids, liquids, and gases, they expand when it is heated, and it contracts when it is cooled. So all solids, liquids, and gases, it expands when it is heated, and it contracts when it is cooled. Now, the particles of a liquid and a gas are in a state of constant motion. Now, because the particles in a liquid and a gas, they are further apart than they are in a solid, because there's more space in it, they are in constant motion, which means that it moves around all the time. Okay, so when a material is heated, the movement of the particles increases and they move further apart. So when we say when the material is heated, we say the movement of the particles increases. And when the movement of the particles increase, they basically move further apart. So you can say this loudly with me. When a material is heated, the movement of the particles increase and they move further apart. And therefore, we say that the materials expand. So we can say it one more time. When the material is heated, the movement of the particles increases and it moves further apart, and we say that the materials expand. So it expands because the particles move further apart, and the particles move further apart is because it is heated. Okay, so now let's see what happens when a material is cooled. So when a material is cooled, we say that the movement of the particles decrease. I'm very proud of myself. I almost drew a straight line. So when the material is cooled, the movement of the particles decrease. And now when it is decreasing, the particles move closer together. Sorry about that. And then we say that the materials contract. So let's say it together. When a material is cooled, the movement of the particles decrease and the particles move closer together. This means that the materials contract. So one more time. When the material is cooled, the particles decrease. That means that they come closer together, and we say that the materials contract. Now, when a material expands or contracts, the size, I want you to remember this. When a material expands or contracts, the size and the number of particles, so it's the size and the number of particles, do not change. The size and the number of particles does not change. Please remember that. So when materials expand or contract, whether you are heating it or whether you are cooling it, the size of the particles do not change. I'm going to tell you what changes now. Instead, it is only the spaces between the particles that get bigger or smaller. So it is the spaces between the particles that get bigger or smaller. So remember that the size of the particles do not change. It is the spaces between the particles that change. During expansion, the spaces get bigger, and during contraction, the spaces get smaller. So I can show it to you in a diagram in the next slide. I hope I have one, and if I don't, then I'm going to draw one for you. Oh, I have one. Okay. So basically, we have seen that the changes in heat energy affect movement of particles, even though there is no change in its state. So let's just say that this is a liquid. Okay. So now at low temperatures, can you see now these circles here are basically I'm looking at the diagram on the right. Okay. So these circles here are basically the particles. Now those particles do not change. What changes is the spaces between these particles. Can you see all these spaces between the particles? Now that changes. Now when it is heated, can you see the spaces grow more? So there's more spaces between the particles. So this is what expands, and it makes the substance bigger. And then when it contracts, say if it was like this, and then the spaces between the particles reduces and it gets smaller. So an increase in heat energy makes the particles move faster. So this is important for you to know, that increase in heat energy, it makes the particles move faster. And when we say a decrease in heat energy, it makes the particles move slower. So I'm going to recap again. An increase in heat energy makes the particles move faster. And when it's moving faster, you can also see that the space between the particles increases. And then a decrease in heat, that means when it is cooling, the particles move slower, and then the space between the particles is much less. So the changes in the rate of particle movements results in the changes in the volume that something occupies. So can you see when we heated this box here, it basically got bigger. It expanded. So the volume increased. Okay. So now we have me explaining it to you a bit more. When the movement of the particles speed up, there is an increase in the spaces between them. An increase in the space between the particles means that the substance expands. So, and this, in other words, we say that the volume increases. So the volume increases when it expands, and it expands because the movement of the particles speed up. And then when the movement of the particles speed up, we say it increases the space between them. Okay, so when the movement of the particles slow down, there is a decrease in space between them. So you could see that the spaces between the particles decreased. Now, a decrease in these spaces between the particles means that the substance contracts. So, in other words, this means that the volume decreases in space. So when a substance contracts, the volume, the space that it occupies, it decreases, and it decreases basically because the movement of the particles slow down, and the movements of the particles slow down because the spaces between them decreases. Okay, so now in general, this the general relationship between a particle movement and volume is the same in solids, liquids, and gases. So this basically applies the movement of these particles in a solid, in a liquid, in a gas. However, the extent to which that it expands or contracts, so that means that how much it expands or contracts, it depends on the different states of matter, which is the solid, the liquid, or a gas. Now you must know that a solid can't expand too much, like in the example of the tin roof. It can't expand too much. And then I'm going to go through other examples for you that puts it into more perspective. But first I want to discuss expansion in a solid and contraction in a solid. Then I'm going to discuss expansion and contraction in a liquid, and then expansion and contraction in a gas. So we say when solids are heated, their particles vibrate rapidly. So when the particles vibrate rapidly, they push each other slightly, and this causes it to expand, the solid to expand. So the amount of increase in a volume depends on the type of the solid. And now similarly, when you decrease a temperature, it causes solids to contract by varying degrees. So when we decrease it, it contracts, the particles get smaller, and it's not always the same for all solids. It varies according to the solid. So when we say expansion and contraction in a liquid, when liquids are heated, their particles move around more. So when liquids are heated, their particles move around more, and they push against each other slightly, which causes it to expand or to contract. So you can look at your kettle boiling. You can start at first from like 0 temperature, and as you can see it heats, you see that bubbles start to form. So that means that these particles are moving around more, and they're pushing against each other, and it causes the liquid to expand, because when you see your kettle boiling, the water doesn't remain at the same level, it goes higher up in the kettle. So that's why it has a maximum level for you to put. Now, as with the solids, The amount increases in volume also depends on the liquid, but in general, the liquids expand more than solids. So basically what this sentence meant is that in solids, yes, the volume does increase, but in liquids, the volume increases more than a solid when it is heated. And this is because the particles in a liquid are not fixed. Then they are in not fixed, that means it is not in a definite arrangement. So it increases the movement and it allows for greater expansion in a liquid. Okay, so we're going to go with expansion in gases. So when gases are heated, their particles move at a greater speed and energy, and this results in a greater space between them, causing the gases to expand. So in gases, there's lots of space between them. So when it's heated, the particles move with greater speed and greater energy. Now, gases expand much more than solids and liquids when heated. And this is because the particles in a gas are not held together. They are in a solid, in a solid and a liquid, but they move in free directions. So, like in a solid and a liquid, when the particles are close together, the gases, they are free and they can move in all directions. Now, when referring to gases that are in a closed container in a fixed size, we do not refer to it in a change in volume. This is because of a temperature of the gas particles that fills the whole container. So I'm going to introduce a new concept to you, which is part of my lesson tomorrow. So instead, we refer to changes in pressure. So with gases, we don't refer it to changes in volume. We refer it to changes in pressure in the container. Now, pressure is a result of the particles colliding within the walls of the container. And the temperature of the pressure, the higher the temperature, the greater the speed of the gas particles and greater the energy and greater the collision. So we say high temperatures in a gas container, we have the greater the speed of the gas particles, which means it has more energy and more collisions in the container. So in other words, we say increase in temperature of gases would result in increase in pressure inside the container. But this I'm going to do more in our lesson tomorrow, because our lesson will consist partly of expansion and contraction of different materials and pressure. But whatever I don't finish in this lesson, I will do tomorrow. So some solids expand more than others. And then let's say if you choosing materials when you're going to do a new job. For example, like you always see them tarring or concreting roads. Now it's important to know how much it will expand. So when you're even fitting windows in your home and stuff, we'll do more of that tomorrow. So you need to know what type of materials to use and how much it's going to expand when it gets hot. So if we look at the diagram below, the picture on the left shows the concrete part actually of a road surface. So basically this is a road surface and it's been concreted. So now how have the engineers built roads to show that allows for expansion and contraction? So can you see each when they were putting in the roads, they left some space in between. And these spaces here, and that I'm showing you on the diagram, allows it for expansion and contraction. But if they don't choose the right materials and they don't have the correct amount of expansion and contraction, what's going to happen if you look at this last picture at the top here, you can see that it's going to crack the concrete or the cement. And I'm sure you have noticed it when your parents were driving, that some of the concrete or the tar roads have cracked. It's because they didn't use the correct amount of correct materials and for expansion and contraction. Now, the picture on the right shows you that there is no allowance over here. Actually, not on the right, the picture in the middle. It shows you that there is no allowance. Here, they showed you that there is allowance. Now, the forces created by the expansion of the concrete are so strong in the road surfaces that it has cracked. So the forces between this plate and then this plate here was so strong that now it caused it to crack. So it is an important principle to remember when building bridges. When engineers design a bridge, they must allow for contraction and expansion of materials to build the bridge. And you have to have a look at the photo that shows that how you close the gap on the bridge. Like if you look here, you can see this plate here, and this plate basically allows, and it has the teeth interlocking, and this teeth interlocking basically allows for the expansion and contraction, so the teeth slides past each other. So I have 10 minutes left for the lessons. Before I move on to expansion and contraction in a thermometer, does anybody want to ask me a question? You can type it in. If you don't, then I'll explain this expansion and contraction in a thermometer. And then whatever questions you do have for me, if I don't see it coming up, then I can go through it like how I did in today's lesson. I can go through it tomorrow. So I'll continue until your questions come up with expansion and contraction in a thermometer. So the common glass thermometer is basically called a bulb thermometer. And all bulb thermometers, they have a fairly large bulb. That is, okay, let's see the question before I continue. Yes, when the particles expand, there's always spaces between them. And this spaces between them allows the particles to expand. So when you apply the heat, you're applying the heat, and the spaces between them makes the particles expand. Okay, that's a good question. I hope I answered it. If you want, I can go through it one more time. So when you heat a substance, no matter what it is, so you're heating the spaces between the particles, and then that's what makes it expand. Then another question is, and this applies to all, the solids, the liquids, and the gas. Yes, you're correct. In all the solids, liquids, there are spaces in each one of it. So then the heat allows the spaces in between to get bigger, which allows it to heat up, whether it is in a solid, whether it's in a liquid or a gas. And just like when you cool the substance, or you make and it starts to contract, the particles both in a solid, liquid, and in a gas, they get smaller, and that allows it to become smaller, which means that it has contracted. Okay, so until I see more questions, I'll continue. So now, a thermometer basically is a thin, long tube, and a thermometer has a brightly colored gas, liquid inside. And some thermometers, they contain mercury as it expands and contracts quite a lot. Now, did you know basically mercury is the only metal, mercury is a metal, but it's the only metal that at room temperature becomes a liquid. So in a thermometer, they're basically using mercury, which is a metal, but at room temperature, the mercury becomes a liquid. Okay. So I'm going to show you two thermometers now, and it's going to have two different temperatures. Now, if we look at the first thermometer on your left, now can you see this gray substance here inside the thermometer? Now this basically is the mercury. Now for this thermometer, it is at 20 degrees Celsius. And now this particles here basically shows the particles of the mercury. Okay. And now this thermometer on your right hand side is at 10 degrees Celsius. Now what I want you to do now, which is cooler, and remember this is hotter and this thermometer is cooler. The temperature here is 20 degrees and here the temperature is 10 degrees. So I want you to think from A, B, C, and D. How do you think in the second thermometer the particles will be arranged? Okay, so while you're thinking, I'm going to ask you some questions. So the drawing, I hope I find my drawing. I think I'm only going to get my drawing a bit later. So the drawings represented the particles in a liquid inside the thermometer. Now, what was the temperature measured in the thermometer on the left, which was the first thermometer? So it was basically 20 degrees Celsius. Then the next question is, the thermometer on the right, it was slightly different. So I'm sure I showed you what the difference was, and the temperature reading of that thermometer was 10 degrees Celsius. Now the question that I asked you, which of the circles, which is A, B, C, or D, is the best representation of the liquid in the thermometer on the right? And why did you choose that one? So if I go back quickly here, so it was A, B, C, or D. Which is the best representation for this thermometer, for the mercury, these particles of the mercury? So let's see what the answer would be. Okay, so the circle A is correct, the one where it was closely packed, because the lower temperature made the liquids inside the thermometer contract, so the particles got closer together. So in the thermometer that had 10 degrees, the picture where the particles were closer together is the correct picture, because the particles were closer and it contracted because of the lower temperature. I should have put this first before. Okay. So I've got it here again. Now I'm going to explain why B, C, and D were not correct. So B was incorrect because the particles were further apart. Okay, then this diagram here on the left, and then C is also incorrect because the particles of the diagram are much further apart, and it's not possible, since the particles cannot gain mass, and then mass cannot be created or destroyed. So an important thing for you to know is that the particles inside basically cannot be created or destroyed. You're not losing or gaining the extra particles in this mercury liquid. It's the same as 10 degrees here. The only thing that is moving is the spaces between each particle. Okay, so the mass and the volume are in a fixed position, and expansion means that they move apart and the spaces between them get bigger. Now, your answer D is also incorrect because the particles in the diagram appear to have grown much smaller. So the spaces between them got very, very small, as opposed to this one here. Okay, so this would have been at a much less temperature. So we're going to more questions. So does the material have less mass when it is contracted? And then we'd explain the answer. The materials cannot have less mass because it still has the same number of atoms as before, and the mass is constant, which is what I explained in the previous slide. So I want you to remember, matter cannot be created or destroyed. Now, if the temperature was raised and the thermometer read 30 degrees, which circle will best represent the particle in the liquid thermometer? And let's see why. So B would represent it because the thermometer has a higher temperature, so the particles gained more energy, and they're moving much at a greater speed, and they are further apart. Okay, so the particles were further apart. And how does volume change when the material is heated? So the volume of the material increases because the particles move further apart, and we say that the material has expanded. So this summary is basically summarizing our whole lesson of what we did so far, but it's just putting things into perspective for you. And then a question, how does density change when material is heated and why? So the mass does not change, but the volume increases. Therefore, the density decreases. So because the volume increases, that means the particles are further apart, then we say that the density decreases. So it's important for you to know that the mass does not change. The volume increases. Now, because the volume increases, that means the particles are further apart, which means that the density decreases. So what you would have learned from today's lesson is basically when a substance absorbs or loses heat and energy, the movement of the particles is affected, and which causes the volume to change. And solids, liquids, and gases will expand when heated due to the increased movement of the particles. Solids, liquids, and gases will contract when cooled due to the decreased movements of their particles. Now, the temperature changes affect the volume of the gases, and most of the volume of the solid. So let me say that sentence again. Sorry. Temperatures change affect the volume of the gases, and the most volume of the solids. I don't think I wrote that sentence properly, sorry. Okay. There are many particles and safely considered associated with expansion and contraction of matter due to the temperature changes. So you remember I told you about practical and safety consideration when you're doing expansion and contraction. You need to cater for temperature changes, so things would stay in its place and it won't crack. And when a material is heated, its particles move further apart. And when the materials cool down, the particles move closer together again. And the heating and the cooling causes the volumes of the material to change. Now, what I want you to do for homework is I want you to basically write me a summary of my lesson. And then I want you to draw the particles, if you can, in a solid, in a liquid, and in a gas. Now draw the particles, one of a solid, and then how the particles will be, you can choose either one, you don't have to do all. So choose a solid, a liquid, or a gas. Draw the particles of how it is in its exact room temperature. Then draw the particles of how it would appear when it is heated, and then draw the particles of how it would appear when it is cooled. And then this will basically help you to conceptualize whatever we learned today. And you can email it to me and I can check it. You can email your summary to me as well and I will check it. So all that information that I derived from here was from Sia Vula's book on the website. And the Department of Education also uses this book. I also used Good Science to gather information on solids, liquids, and gases, which gave you a better understanding of it. Now, a nice video for you to look at is this YouTube video here, Expansion and Contraction of Solids, Liquids, and Gases, because it will help you learn visually as well. and then expansion and contraction. Now the first video is a 2 or 3 minute video, and the second one that I have, expansion and contraction, is basically a 1.5 minute video. So our next lesson will basically be density of different material, expansion and contractions of different materials, and also pressure. And my email address, in case you want to send me your answers, is ahaffea@gmail.com. Okay, thank you so much. I hope you enjoyed my lesson. So this is my email, ahaffea@gmail.com. If you need any information, please feel free to contact me. I did enjoy this lesson, and have a lovely day. Goodbye.